Hi, Alex. Hi, Charlie. Okay. Before I get started, um, this is the exact practice test I gave you last week. I think it was last week. I'm gonna go over every single question, as in depth as I can, and I'll try and fill in gaps. Um, but as I go through these, um, ask questions. I'll keep my eye on all of this stuff. Um, but don't be afraid to ask. If you want to email me for whatever reason. If you don't want, you know, the entire chat to know, which is only like 6 people right now. Um, if you have to leave, that's fine. This is hopefully going to be back up shortly after. It probably won't be up immediately after. So if you do have questions, I would keep this tab open, and then you can kind of rewind and fast forward and all that stuff. Um, but if you have to leave and come back, that's fine. This is here for you guys. So if there's questions on here that totally make sense, and you feel like you know the rest of it, then that's fine. Um, but if there are questions that you know I'm going to get to pretty soon, stick around and then you can ask questions about it. Or if you do have to leave and you still have questions, be patient because this will be up at some point. Okay. Um, so I think the easiest thing right now is just go. All right. Um, so we're just gonna go through one all the way down. Just as a quick kind of glance. Um, 1, 2, 3, and 4, 5, and 6. Those all have to do with lines. Okay, so this is all stuff that has to do with the equations y equals mx plus b, y minus y1 is equal to m times x minus x1, and in general, just to find slope, which you have to do for pretty much all of these. That's the change in y over the change in x. Okay, so that's what the first like 6 are all about. Okay, perpendicular has opposite reciprocal. We'll go over this here in a second. Parallel has the same. After that, we go into factoring. So we go into factoring quadratics, both easy and hard. Then we go into using the quadratic formula, graphing quadratics, a little bit of inequality work, back to quadratics. I don't know why I didn't put that in different order, but that's fine. Matrices and systems, solving regular equation, and then the special cases that we just started going over. Okay, and I'm going to try and spend a little bit more time on those than I do everything else. But hopefully all of this stuff you've seen, well, all of this stuff you've definitely seen before because we've tested over it. We've done it a lot in class. So this is nothing new except for these last couple of problems. All right. Is the format of the practice test going to be the same as the final? Yes. Yeah, as it normally is. If I change anything, it's more of like a either order of question or usually it's changing to make it easier. But I already printed off the test, so have fun. All right. Great. Sketch the graph of each line. We just got to know, we got to identify slope. So slope in this case is -4/3, right? Slope is rise over run. How many points is the final worth? The final is 15%. Okay, so it's worth about any other test. If it's a little bit over, it's a little bit over, but I think most tests are actually heavier weighted than this. The test is not going to be 40 questions. The test is exactly like I gave you before. Anyway, slope, right, -4/3. It's this guy. And then our y-intercept, that's 2. So we plot that point. Right, that's our b. Then we go down 4 and over 3. Then we draw a line through those 2 points. And we're done. That doesn't look great, but you get the point. Okay, that's the easiest problem. Again, this is stuff that you've done all through Algebra 1. I'm not super worried about this. We should get that pretty easily. The next one is a little bit different because it doesn't give you it in a form that you're used to. Okay, some of you may have gone over standard form of a line at some point, that's what this is. But what I would do is get it to a form that you know how to use. So I'm going to subtract over the 2x and then divide everything by 3. Right, so we get this equation, and that tells us how to graph, right? So -2/3 is our slope, -5 is our y-intercept. Okay, there's not enough room to go down, so I'm going to go up to left 3. So we get a line defined by those points. And that's our line, okay? That's all I'm expecting. I just want you to be able to graph a line, which I think is pretty simple to do, okay? Number 3, we're at the slope-intercept form of the equation of each line. I don't care about slope-intercept. It can be any equation of the line so long as it's correct. All right, but this is actually easier in slope-intercept. Okay, we identify our y-intercept. So we identify our b, that's -1. And then we identify our slope. So we go up 1, up 6 over 1. Right, so m is rise 6, run 1. So it's just y is equal to y is equal to 6x minus 1. There are other versions of this. Okay, I think this is the easiest, so I'm going to just stop here. But that's numbers 1, 2, and 3. Those should be really, really easy. Okay, where it gets a little bit harder is number 4, where I'm just giving you 2 points. Okay, again, I don't care what type of equation it's in. I left that on the test, but I'll tell you tomorrow. When you're given 2 points, really for any equation of a line, we need the slope first, right? So m is the difference in y's over the difference in x's, right? So we just label these x1, y1, and x2, y2, and that'll come in handy later too. Y2 is 5, y1 is 3, x2 is 4, x1 is 2. So we get 2 over 2, which is just 1. So that's our m. Okay, we have m, but we have m, so we have slope and 2 points. Okay, what I would suggest is to use this point slope form, which makes this way easier. Okay, because all you have to do is just plug in stuff, right? So the y's stay the same, so you have y minus y1, which is 3, equals m1, and then x minus x1, which is 2. And then that can be your equation. There are other versions of this. Okay, you could use x2, y2. Okay, so that version works, that box equation works. But you could also do y minus 5 is equal to 1 times x minus 4. And then if you really wanted to, you could simplify either one of these down to slope-intercept. Okay, either one works. It's whatever you feel comfortable with. Okay, you're going to get the same answer, though. And you can check that if you would like. All right. And then it's probably the more complicated ones. Okay, so 5 and 6, as long as you know what parallel and perpendicular mean, honestly, you're fine. Okay, so we're trying to get the equation to line through 3, -4, parallel to the line y equals -x plus 4. Okay, because it's parallel, we know it has the same slope as that equation, right? So the slope in this equation is just -1. And then everything else is the same that we did above, right? You could just do y, in this case, plus 4 is equal to -1 x minus 3, and then you're done. Okay. Similar on the right. Perpendicular means, you know, they're coming, those lines are intersecting at a right angle. Okay. For a perpendicular line, our slopes need to be opposite reciprocals, right? So all we do is we take this slope, we flip it upside down and make it negative, right? So that means our new slope is -1/2. Everything else is the same, right? So we just do y minus 1 is equal to -1/2 x minus 4. And then that can be our answer. Okay, so that's the line portion of this. Again, these should be easy points. If you have questions over this, let me know. But I'm assuming we don't, so I want to keep moving forward. But if you do, again, just type it in, and I'll answer it as soon as I see it. Okay. Really, the rest of the test, besides like 2 questions, which are the inequality question and, well, the systems one. The rest of the test has to do with factoring or quadratics. Okay, because that's like the main theme of Algebra 2. If you're able to do those 2 things, deal with quadratics and deal with factoring, you're able to do pretty much everything else. Okay, if you're able to understand those couple of concepts. So when I say solve each equation by factoring, right, we want to factor the left-hand side and then solve for, in this case, b. All right. Hijack height. So what we need to do, there's 2 different types of these problems. There's one that's going to be really, really easy, and then there's one that's a little bit more involved. For this easy one, right, and by easy, I mean that the leading coefficient, right, that thing attached to the b squared, it's just 1. Okay, so whenever your leading coefficient is 1, these are really easy problems. So what you want to do is you want to ask, what are factors of 12 that add to 8? Okay, so you can do a factor tree. You just got to make sure you get it right, right? So 1 and 12, 1 plus 12 doesn't equal 8 though. 3 and 4, 3 plus 4 equals 7, so that's not what we want. 2 and 6, 2 plus 6 is 8, right? So these end up being our factors. Okay, so in order to factor this polynomial, this quadratic, we would do b plus 2 times b plus 6 is equal to 0. And you can check this by refoiling this out. Okay, you don't have to. I would suggest doing that. And so long as you get our original problem, you know that you factored it correctly. All right, but this is only the first part of the problem, right? So this is the factoring part. So that's worth, I think, 2 points if I remember right. And then there's the actual solve part. Okay, so when we solve, we have a product of two things that's equal to 0. So one of those two things has to be 0. So we set both of them equal to 0. So b plus 2 is equal to 0, or b plus 6 is equal to 0. So b is equal to negative 2, and b is equal to negative 6. Those are our two answers. Okay, reason being is because if you plug in negative 2, right, this first factor, that's going to be equal to 0. So you're doing 0 times a number, and no matter what that number is, it's going to give you 0. Same thing for negative 6. If you plug in negative 6, right, you get negative 4 where it's highlighted yellow, but then you would get 0 where it's highlighted blue. Right, so negative 4 times 0 is 0, and then you have your answer. Okay, so that's kind of what I'm expecting, those two parts, right? Right, the actual factoring part and then the solving part. But that one's a little bit easier. Okay, where it gets a little bit harder is when we get to quadratics where our leading coefficient is not 1. And there's not a whole lot more thought here. There's like one extra step. Okay, so I'm going to look at this as in terms of an area of a big box. Okay, and we know two things when we're doing this. We know the area of this top left-hand square box, whatever you want to call it. That's going to be 7n squared, right? That's our first term. And then we know the bottom right-hand corner, which is 32. Okay, so our job is to get factors here, 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 and here, right? So we're essentially we're getting a length and a width. Okay, so factors of 7n squared, 7n and n. And then factors of 32. Okay, so this is where you kind of got to guess and check, right? So 7n times n, we know that that's 7n squared. All right. Then we need to figure out factors of 32 such that these two boxes add up to 36n. Okay. So in order to do that, right, 32, 8 and 4, I think are two factors, right? And this might take some guessing and checking. So I'm just going to write 8 up here and 4 down here. Okay. Then this is a multiplication table, and all we're trying to do is add up two different boxes and see if it's equal to what we want it to be. Okay, so 7n times 4, right, that's going to give you 28n. N times 8, that's going to give you 8n. And then our check to make sure that this works is that 28n plus 8n is equal to 36n, right, which it does. Right, it equals this middle term, so we know that those are our two factors. Okay, so really what we just did is we found a length, this 7n plus 8, and a width, this n plus 4. And if you FOIL that out, you get this left-hand side of this equation. Okay, we know it's equal to 0, so then we have a problem just like the one to the left. So either 7n plus 8 is equal to 0, or n plus 4 is equal to 0. And then we just solve as normal, right? So n is negative 8 over 7, and n is equal to the negative 4. Right, those would be our two answers. Okay, worth the same amount of points as the last one, just a little bit more involved, right? So this is still worth 2 points, and this is each one of those are worth 1. Okay, next is the quadratic formula. Okay, and just so we have it. Yeah. Okay. Quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All we're doing is using this and simplifying as much as we can. All right. So for this number 9, we get that p is equal to negative b, right? In this case, b is this negative 6. So we get negative negative 6 plus or minus the square root of b squared minus 4 times a, which is 12, and c, which is 6. Okay, one word of caution here, and this is all over 2 times 12. Okay, one word of caution is this this negative 6 squared. Some people are doing negative 6 or 6 times 6 and then just adding a negative up front. We're taking that entire negative 6 and we're squaring it. Okay, because b is negative 6. So b squared is negative 6 times negative 6, which is just positive 36. Okay, so if we simplify, we get 6 plus or minus 36 minus this is where I need a calculator. Can I look at my cast on the test? No. It's got the quadratic formula. You can deal without it. So 36 minus 4 times 12 times 6, which is 288. All over 24. Okay. Now, thank you. Now we just simplify, right? So these are also each worth 4. Okay, so 1 for actually knowing the formula, and then you're going to get 1 more for simplifying all the way. So we get 6 plus or minus square root of negative 252 over 24. Okay, so this is worth, everything here that you see so far is worth half credit. Okay, where you get the other half credit is actually being able to simplify this square root of negative 252. Okay, now, this is where the imaginaries come in. Okay, so I'm going to take the square root of negative 252 over here. And we can rewrite this as the square root of negative 1 and we can take a 4 out of 252. Actually, we can take more out of that. Okay, so I'm going to go through the process I do, which is literally just dividing it by 2 a bunch of times. Right, so we can rewrite the square root of negative 252 as the square root of negative 1 times the square root of 2 times the square root of 126. Okay, you can make this faster by pulling out bigger factors, but this is kind of like a guaranteed way that works. Okay, we can go further by simplifying this square root of 126. Right, so those 2 things still remain there. I'm going to pull out another 2. We get 63. Okay. Rad 2 times rad 2 is just 2. Square root of negative 1 is I. So far this is equal to 2I rad 63. Okay. This is great, but you can still go further. We can rewrite rad 63 as rad 9 times rad 7. Rad 9 is 3. So we get 6i rad 7. Okay, and that takes the place as this square root of negative 252. So our answer here is 6 plus or minus 6i rad 7 over 24. Right, you can stop there. Okay, this other half of the credit, okay, and it may not be number 9. I think it's number 10 on the test. But if you have an imaginary, right, so if the thing underneath the square root is negative, you get half credit for simplifying to that point, but you get half credit, the other half credit for actually simplifying the imaginary part. Okay, this part in red, that's simplifying the imaginary part. This part in green is just knowing the formula. Okay, and that goes for it for both 9a and 10. All right, so for number 10, you do the same thing, except I think this works out a little bit cleaner, right? So negative b, so negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times negative 14, right? C in this case is negative, right? That's the C, over 2 times 4. And then we just simplify, okay? One of the things that I've been seeing my seniors and juniors mess up a lot on is when you have this negative times a minus, okay? Negative times negative is always positive. It doesn't matter what order you're multiplying. Okay, so when we simplify this, we get negative 3 plus or minus the square root 4 times 4 times 14. We get 9 plus 224 over 8. And then we just simplify from there. So 224 plus 9. Yeah. Square root of 233 all over 8. I don't think we can simplify that. Okay, so I think this is our answer. But again, the same goes as number 9, right? There's 1 point for actually knowing the formula. There's 2 points for simplifying. And then your final answer is worth 2 points. Okay. This final answer needs to be simplified as much as it can be. Okay, I'll be a little bit lenient on that. Like on number 9, if you stopped like here, I might be okay with it. But the goal is to be able to simplify radicals. Where'd you get the gaming chair? Just an office store. Okay. Number 11. Find the zeros in the vertex of the following, then sketch the graph. If there are no real zeros, find the imaginary zeros, plot the vertex and the y-intercept. All right. So we're really just kind of pulling those last two things that we did together and then adding the graphing in the vertex. Okay. Vertex is really easy to find. You can either complete the square, which actually shows up later in the test, or you can do negative b over 2a and then plug that back in. Right, so then we get 8 over 2, which is 4. So that's the axis of symmetry. It's not quite the vertex yet. It just gives us where the vertex is. Okay, in order to get the second part of the vertex, you plug that 4 in. Right, so 4 squared minus 8 times 4 plus 12. This is 16 minus 32 plus 12. I think that's negative 4. Yeah. Yeah. So then our vertex is these two things combined. So you get 4 comma negative 4. So then our vertex is right there. Okay. How do you find imaginary zeros? I mean, we did this number 9. These are imaginary zeros because there's an I involved, right? So whenever you have a square root of a negative number, that's when an imaginary zero comes up. Okay, we didn't do anything special. We're still using the quadratic formula. It's just when we simplify, we notice that there's a negative underneath the square root. And then because of that, we have to pull out that I. And once we do that, we have an imaginary zero. So 6 plus or minus 6i, rad 7 over 24. Those are two imaginary zeros. 6 plus and then 6 minus. Okay. So number 11, we found the vertex. That's 4, negative 4. Then we need to find the zeros. And you have two different ways to do this. You can either use the quadratic formula, which we did up here, or you can factor, which we did before that. Okay. This one is way easier to factor because we just need factors of 12 that add up to negative 8. Okay. So if we do that, we get x minus 6 and x minus 2, right? And you can FOIL that out to make sure, but you should know that you're going to get x squared minus 8x plus 12, right? X squared minus 2x minus 6x, which is negative 8x, and then plus 12. And then we just get x equals 6 and x equals 2. We kind of connect the dots. And then really we're done. Okay, so you find zeros, negative b over 2, or sorry, you find zeros by factoring or using the quadratic formula. And then you find the vertex by doing negative b over 2a and then plugging it back in. Okay, this is like 2 tests ago. Okay, solve each inequality and graph its solution. So with this, you treat as algebra first, right? So we want to get 7x plus 10 by itself. So in order to get it by itself, we need to multiply by 5 on both sides. Right, in order to get this 5 out of the denominator, we multiply by 5 up top. And what we do to one side, we have to do to the other. Right, so when we do that, we get the absolute value of 7x plus 10 is equal to 10. Now, absolute value means distance. Okay, so what this is actually saying is that the distance from 0 of 7x plus 10 is greater than 10. Right, so what that means, if you draw it out, and you don't have to do this, I'm just trying to explain it for people who don't understand. If we have this number line, okay, our distance from 0 is going to be, this distance, this 7x plus 10 distance, is going to be outside of 10 or outside of negative 10. Okay, so if we just think about that, then we get 7x plus 10, right? That thing inside is going to be greater than 10, or 7x plus 10 is going to be less than negative 10. And then you just solve, okay? Keeping in mind that if you ever multiply or divide by a negative, you have to flip the sign. In this case, you don't have to, right? So we just subtract 10 over from both sides. So you get 7x is greater than 0, so x is greater than 0. And then over on the right-hand side, you get 7x is less than negative 20, so x is less than negative 20 over 7. This is the first part of your answer. Your second part is the actual graph. Okay, so for this left-hand side, right, we find 0, we put an open circle, and we go the direction the arrow is pointing in. Okay. For the right-hand side, right, that's about negative 3. It's a little shy of negative 3. So you put an open circle right around there, and then you follow the arrow. Right, then that is your answer. Okay. I'm expecting both. Number 13, so we get back into quadratics for a quick second. Find the vertex by completing the square. Okay, so we know how to find the vertex from up above. That's negative b over 2a, and then plug that back in. But I'm asking you to do completing the square instead. So when we're completing the square, the one thing we're worried about are the first two terms, n squared minus 18n. And we're going to put that inside a perfect square. Okay, so n squared goes up top. And then we need to split up this middle term into 2. So we get negative 9n and negative 9n, right? Because our length and our width have to be the same in order for us to have a perfect square. Okay, so factors of n squared, that's n and n. What percent of our grade is the final? I'm going to let you look that up because I've said it a couple times. It's in the syllabus. We've said it a lot in class. And then factors of negative 9n, that's negative 9 and n. Okay. So then we have a length and a width. Right, we have n minus 9 and n minus 9. So if we start to write this, we get n minus 9 squared, which is what we want. Minus 67 is equal to 0. But what we added in here is this negative 9 times negative 9 as well. So we added this 81 that wasn't originally in this box. Okay, so inside this n minus 9 squared, we added an 81 without doing anything about it. So in order to balance out our equation, right, what we do to one side, in this case adding 81, we have to do to the other. Right, and if we simplify that, or if we get this 81 to the left, we get n minus 9 squared is equal to, what is it, 14? So plus 14. Right, and then this means our square is completed. And then the vertex, what I'm actually looking for, is 9 positive 14. Right, it's the opposite of what's inside and exactly what's outside. Okay, it's been a while since we've done that, so I want to make sure people understand it. So I want to just like pause for a second and have people look over it. If you don't, that's fine, but in case people have questions, I want to sit here for just 2 seconds. For number 14, can you use the elimination method? Yeah. Solve each equation using any method. You can use substitution, you could use elimination if you wanted to, which some people did. They used Cramer's rule. You can graph it, whatever. You just got to show me. Okay. So number 14, 15, and 16 all have to do with the last test that we took. All right. So this 2 by 2, this one should be the easy one. You pick, again, you can do this in whatever way you feel comfortable. I'm going to eliminate, and I'm going to eliminate y. So, yes, I'm going to do it as the example because that's the easiest way to do this, I think. Okay, so I'm going to take this bottom one. And what we need to do is we need to get the same magnitude of y with opposite signs. So I'm going to multiply this bottom one by negative 3. And when we do that, the top one stays the same. And then we get negative 3 times negative 10x, which is 30x. Negative 3 times 2y, which is negative 6y. And then negative 3 times 18, which is negative 54. Okay. And we did that so these y's cancel, right? So 6y plus negative 6y is just 0. We get 21x is equal to negative 54 plus 12, which is negative 42. Divide by 21, and you get x is equal to negative 2. Right, so that's the first part of your answer, but it's not everything, okay? So once you solve for x, you gotta solve for y. Right, so what we do is we just plug this into one of our originals, so we get negative 9 times negative 2 plus 6y is equal to 12. So 18 plus 6y is equal to 12. 6y is equal to negative 6, so y is equal to negative 1. So that's the 2 by 2 system using elimination. The next one's kind of the same, except there's 3. All right. So what we need to do for systems of 3 equations, we need to pick 2 equations, eliminate 1 variable. Then we pick another 2 equations and eliminate the same variable. And once we do that, then we have a system of 2 equations and we solve just the same way we did above. Okay, so I'm going to eliminate x just to stay on the left. All right, so I'm going to take these first 2 and I'm going to multiply the bottom one by -4. So the top stays the same. Multiply the bottom one by -4, so we get 4x minus 16y minus 8z is equal to -44, positive 44. And when we do this and add them together, we get -12y minus 7z is equal to 19. Okay, so that's the first half of the first part, right? Then I'm going to pick another 2 equations. So I'm going to pick these bottom 2. I'll do this in green. So -x plus 4y plus 2z is equal to -11. And then x minus y minus 5z is equal to 11. Right, we just add those 2 things together. So we get 3y minus 3z is equal to 0. So now what we have is we have a system of 2 equations. Okay, we have this guy in red, and then we have this guy in green. So we just solve those, right? So what I'm going to do is I'm going to multiply this green one by 4. And when I do that, we get 12y minus 12z is equal to 0. So what we get, I think I did this right. Yeah. We get negative 19z is equal to 19. So z is equal to -1. All right. Once you get this, everything else is downhill and all it is plugging in. Okay, so what we're going to do is we're going to pick, so once we have that thing in blue, once we solve the first part of this system of 2, we have to solve for the second part of the system of 2. So we have z, we need to solve for y. So I'm going to take 3y minus 3z, which now we know is -1, is equal to 0. So we get 3y plus 3 is equal to 0. So y is equal to -1. And then once we have those 2, we pick one of our original 3 and plug it in to that. Right? So I'm going to take it on the side. So let's do x minus y, which is -1, minus 5z, which is -1, should be equal to 11. So we get x plus 1 plus 5 is equal to -11. So we get x is equal to -17. Okay. I said this to my seniors and juniors. I really care about the process for this. If you screw up a negative somewhere, it's not going to be the end of the world, especially if I can see your thought process. So as long as you're neat and you're like, all of your steps are really very clear, and you do it right, you're going to get most of the credit. Okay. Again, fudge a negative or a constant somewhere, that's fine. Positive 11. You're right. Right, so what I just did just here, right? I put a negative in where it shouldn't have been. Okay, that's fine so long as I see everything else. Right, so this would be -5. And I want to emphasize the be neat part, because last test a lot of people were not. There was just like work everywhere. And you're only getting this much room. Okay, so be concise, be consistent, but be efficient. Right? So that's number 15. That's probably the longest part. That's probably the longest problem. Everything else should go pretty smoothly. Okay. For Cramer's rule, we're solving another system of 3, but we're using a different technique. Can we make a cheat sheet on a note card? No. No. I'm sorry, but you cannot. You'll be fine. So Cramer's rule, the first thing we need to do for Cramer's rule is get a coefficient matrix. All right, so -5, -5, -4. Nope, that should be 0. And you have to be very careful about what your coefficients are, right? So the first column is your x column, the second column is your y column, and then the third column is your z column. And what we need to do with this coefficient matrix is we need to take the determinant of that, right? Because the determinant, like we discussed in class, that's the denominator of our x, y, and z. So we repeat these first two columns. And we take the product of the diagonals and the sum of each one going in the same direction, right? So this would be -5 times 1 times 4 plus -5 times 5 times 0 plus -3 times -5 times -4. Okay, we do the same thing with the other direction. So we had 0 times 1 times -3 plus -4 times 5 times -5 plus 4 times -5 times -5. Okay, so you're going to get two numbers. You get a number in green and you get a number in red. You are subtracting those two. Okay, and it also has to be in this way. Okay, so you're taking, right, the diagonals in green, you take the product of the diagonal, add those diagonals together, and then you're taking the diagonals in red. Okay, so if we do a little bit of math here, this top part, that's -20 plus 0 minus 60. 3 times 5 is 15 times 4, yeah. And then on the bottom, we get 0 plus 100 plus another 100. Okay, and we're subtracting these two numbers, right? So we get -80 up top, minus 200, and we get -280. You can check this on your calculator. Okay, you can do that determinant on your calculator, but I'm expecting to see this work, right? So if you do get it, if you know how to get a determinant on a calculator, that's fine. You're only using that as a check, though. Okay, I want to see you be able to do it by hand, and there's reasons why. Okay, this stuff becomes important way later on, but if you're just able to do it on a calculator, it doesn't really help you. Okay, so our determinant of our coefficient matrix is -280, and the rest is decently easy. All you're doing is setting up x, y, and z. Okay, so x is going to be the determinant of this x matrix, right? And by that, I mean you're taking the x column and you're replacing it with the answers, So -3, -16, and 8. And then everything else in the coefficient matrix is the same. Right, so you would take the determinant of this and then put it over -280, and that would give you x. For y, you do the same thing, except you're replacing the y column. And then the same thing for z. Okay, once you do that, I'm not looking for answers. I just want you to set it up. The above work in red and green tells me that you can take a determinant. I don't see the point in doing that 3 other times. Okay, so you set up x, you set up y, you set up z, and all the work you see here is full credit. Okay, I think this question is worth like 8 or 9 points. Okay, the determinant, right, finding the determinant by hand, this part, that's worth 3. Setting up each one of these is worth another 1, and then there's another 2 with at least setting up the determinant the correct way. Okay, so if you're able to get the correct determinant, you get like 5 points. Everything else is setting up the actual Cramer's rule. Okay, so that's number 16. Again, that's one of the longer ones, so just be careful. Number 17 is literally just there as a freebie. Okay, you add 8 to both sides, you divide by -7, and so on. Okay, so if we just do this, we get 133 is equal to -7 times 2 minus 7n. Right, 125 plus 8. Yeah. We divide by -7. Okay, this ends up being 19, -19. Subtract 2, so -21 is equal to -7n. So n is equal to 3. Okay, shouldn't be very difficult. Just want you to be able to do it. Everything else on this test is new material. Okay, so all of the rest, and it's not really new, just parts of it are new. Okay, but it all has to do with factoring. Okay, so before we get to this, there are really one major idea, and that's just different ways to factor different things. Okay, and we went over 3 different like special cases. Really 4. Okay. There is, for 16, we don't have to plug all that stuff into our calculator. No. Again, you can use it to check, and I highly recommend doing that. But in terms of showing work, this is all I want you to show. Again, I would encourage you to if you have time. But if you're able to set this up, at least somewhat correctly, and by somewhat I mean mostly, you're going to get most of the points. Okay, so this is the work I want you to see. Or I want to see. Okay. Yes. Yeah, you don't have to plug it in. Okay. For the rest of this test, though, we discussed a couple of different like special cases of factoring, and that is the difference of squares, the difference of cubes, and the sum of cubes. Okay, and each of these can be factored in really, really simple ways so long as you memorize like the formula. And I get memorizing isn't always the best thing to do, but in this case it works. Okay, a squared minus b squared, that's always going to be a plus b times a minus b. Okay, and these work both ways. Okay, a cubed minus b cubed, that is a minus b times a squared plus ab plus b squared. And a cubed plus b cubed, that's a plus b times a squared plus ab, sorry, minus ab plus b squared. Okay, so these are like the three like special cases. The other one is really just a simple thing that we did earlier, and that's the perfect square, right? So a plus b squared, which is just equal to a squared plus 2ab plus b squared. I'm not as worried about that one because you should be able to factor that anyway. So we already know how to do that, okay? But it shows up. The other thing that we covered is factoring by grouping, okay? But factoring by grouping, it seems like a lot of you already know. Some of you might not, that's okay. We did go over it. But factoring by grouping, and this is number one, all we really do is we combine two terms, sets of two terms, and we try and pull out a common factor. Yes, okay. So in this first term, I'll do this in red. Okay, the greatest common factor here is 5p squared. If we pull out 5p squared from 25p, we just get 5p. If we pull out 5p squared from 40p, we get plus 8. Right, so if you were to redistribute that, you would get the original. If we take out a greatest common factor of these last two, right, I could pull out a negative 4, yeah. And what's left would be 5p and then minus or plus 8. Right, so if you redistributed this part in green, you get this stuff up here, okay? Once we do that, once you group two terms together and take out common factors, we can treat this now as two separate terms. Right, so this is its own term and this is its own term. The greatest common factor between those two would be 5p plus 8. So if we factor out a 5p plus 8, we just have to ask ourselves what's left. Okay, so the only thing left when we pull 5p plus 8 out of 5p squared times 5p plus 8 is just the 5p squared. If we pull that same thing out of negative 4 times 5p plus 8, what's left is just that negative 4. Okay, and once we get this, we're totally factored. Okay, sometimes you might be able to factor it completely, right? So you might be able to factor this part right here. I'm not worried about that right now. I'm just worried about you being able to show me that you know how to do factoring by grouping. Okay, so that's problem number one on this like second part. Okay, number two, and the rest these are just applications of these special cases. All right, 4x squared plus 12x plus 9. Again, if I had given you this any other time, you would be able to do it. Notice that we have something squared and then something squared. Right, so if you do a is equal to 2x, b is equal to 3. Right, a good thing to try is just 2x plus 3 times 2x plus 3. And then you can foil that to make sure, right? So 2x times 2x, that's 4x squared, plus 6x, plus another 6x, that's 12x, and then plus 9. Right? And if I talk too fast, that's all I did. Okay. All I'm asking you to do is to factor that 4x squared plus 12x plus 9. You can do it in a lot of different ways. You could use the box. You could use the rule up top that I wrote. Just need to be able to factor it. Okay, so there will be one like perfect square binomial. Okay, the other one, this number 3, that is the difference of squares, right? So you have a is equal to 2v, b is equal to 1, right? And we can use this a squared minus b squared is equal to a plus b times a minus b. Right, so if we do that, we get 2v plus 1 and 2v minus 1. Okay, you have seen this before, right? These two things are called conjugates, and we dealt with those when we were simplifying radicals. Okay, it just so happens when you multiply something by its conjugate, the middle terms cancel out, right? So 2v times 2v, that's 4v squared, minus 2v, plus 2v, and then minus 1, right? And you should see that we get the original. That's just a way to check. This is what I'm looking for. And then number 4 and 5, that has to do with the difference of cubes and the sum of cubes. So I'm going to rewrite those. Okay, so those are the rules we're using. The tricky part, though, is being able to make it look like one of these two things. Can you move the red down? Oh, yeah, sorry. I'll just make myself smaller. I don't need to be on here anyway. I'll do this. No, I'll just be up here. The trick is making it look like what I have written in red. Okay. So number 4, for example, there's nothing that's cubed that can give you 81. There's also nothing cubed that can give us 375. Okay, so we have to be a little bit clever here. And try and factor some things out that make it look like something cubed minus something cubed. Okay, both of these, and this might be hard to figure out up front, we can factor out a 3 from both. And when we do that, we get 27 minus 125 m cubed. And then we're just worried about this thing inside, right? So then we have a is equal to, right, so this will be a cubed. Nope, I didn't want to do that. Okay, so we'll say 27 is a cubed. So a is 3, right? 3 cubed is 27. And we'll say that b cubed is this whole thing. Okay, so b is going to be something times m, right? We got to figure out the cube root of 125. So what times itself 3 times is 125. You could try 4, you could try 6, you could try 2, whatever. 5 times 5 is 25, times another 5 is 125. So b in this case is 5m, right? And then all we're doing is we're plugging into that formula, right? So a is 3, b is 5m, and we're using this distance or this difference. So then we get, let's see, 3 minus 5m times a squared, which is 9, plus 3 times 5n, which is 15m, and then plus b squared, which is 25m squared. Right now, this is all I'm looking for, okay? It says factor completely. If you're able to get to here, right, and actually use these formula, that's all I'm looking for. Okay? You're going to do the same thing on number 5, okay? You have to ask yourself what times itself is 128m cubed and what times itself is 2. What times itself 3 times is 2, okay? And again, there's nothing, right? Nothing cubed is 2. or no integer cubed is 2. So we have a little bit of work to do first. Okay, greatest common factor between them is just 2. So if we pull out that 2, we get, what, 64? 64m. And then plus 1. And then we have the same thing, right? So in this case, a is 4m. Right, I guess if you want to create another step, you can. Right, a cubed is 64m cubed. So a then is 4m. B cubed is 1. And then b is just 1 as well, right? And then we're doing the same thing. So then we have 2 times, right? In this case, we're using the sum of 2 cubes. 4m plus 1 times 4m squared. So that's 16m squared. Minus 4m plus b squared, which is just 1. Right, so again, the trick here is taking out that 2 first. Okay. I realize this is a lot of me talking, especially. I want to give people a chance to kind of look over this just to make sure. So I'm going to start at the very top. I'll scroll down pretty slowly, and as you have questions, ask. Put the number you have a question about in, because there's a little bit of a lag. I think it's like 8 seconds or something. So I'm going to mute myself. I'll scroll through the entire thing, and as you have questions, just ask. If there are no questions, I'll end this in the next like 5 or so minutes. Okay. So I'll scroll up and scroll down. You're welcome, Michael. You're welcome, Alex. You are welcome, Patrick. Will the last 4 problems be on the test? Yes, they will be on the test. Just like the practice test. Do Terry and I get extra credit? No. Sorry. Oh, for the one problem, yeah, I'll figure that out later. If you did it, you will. On an entirely different note, it should be illegal that Snapchat is talking to me through my earbuds. From like that's not right. That's fine. Okay. So that's a quick scroll through of everything. If you have questions, great, ask. If you don't though, and no one else does, I will close this in the next like 2 minutes. All right. So I'll mute myself. If you have questions, by all means, go ahead and ask. I'll answer them. If no one does within the next two, I'll call it a day. All right. No questions regarding math. There's no one I give about my mic. Um, I'm gonna call it. So good luck tomorrow, and I'll be around in the morning if you have questions. So feel free to pop in. All right. Thank you for watching.